So there are two different types of probabilities. First, we can talk about experimental probability or empirical probability, and this is determined by observing numbers of outcomes. So if you flip a coin 20 times, you would get the experimental probability of landing on heads by the number of times your experiment resulted in you landing on heads. However, theoretical probability is the outcome under ideal conditions, or the outcome that we expect to have. So the probability of flipping a coin landing on heads is 1/2, because there are two possible outcomes and heads is one of them. But the experimental probability, if you flip a coin 20 times, you might land on heads 12 times or 15 times even. So these are different. Equally likely means that one outcome is as likely as another, and a uniform sample space is when each possible outcome is equally likely. If we want to think about the relationship between experimental and theoretical probability, Bernoulli's theorem, or the law of large numbers, tells us that as the number of trials of an experiment increases, the experimental probability approaches a fixed number, which is the theoretical probability. So the more times we flip our coin, the closer we should observe that experimental probability approaching 1/2. If we have an event with equally likely outcomes, then we can always find the probability of an event happening by comparing the number of outcomes in the event space to the number of outcomes in the sample space. So the probability of an event A is just the number of elements of A, or the number of outcomes in that event space, divided by the number of elements of the sample space. So N of A over N of S, or the cardinality of the set A over the cardinality of the set S. So if we think about an example where we have the numbers 1 through 25, the natural numbers 1 through 25, and we're going to choose a number at random, that means that all of the numbers have the same chance of being drawn as the others, so it's a uniform sample space. We could find the probability of the event that we draw an even number. So that event A would contain the outcomes of drawing 2, 4, 6, 8, up to 24 evens. So there are 12 possibilities in the event space A. The sample space has 25 in it because we're counting the integers 1 through 25. So the probability of drawing an even number is 12 over 25. If we want to find the probability that we draw a number less than 10 and greater than 20, there are no numbers less than 10 and greater than 20. So the event B is actually an empty set. So there are no elements in it. So the number of things in B is 0. So the probability of B happening is 0 over 25, or 0. The event C is that we draw a number less than 26. All of our numbers are less than 26. So the event C is actually just equal to the sample space. So there are 25 things in the event C, and so our probability is 25 over 25, or 1. If we think about the event D, that a prime number is drawn, we need to figure out what all of the prime numbers are between 1 and 25. And those prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23. So there are 9 prime numbers in that possibility, in that event. So the probability of drawing a prime number is 9 over 25. Then lastly, if we think about the event E, that a number is both even and prime, we can look at our set of prime numbers and see only one of those possibilities is even. So the event is just the outcome of drawing a 2. So the number of things in that event are 1, so the probability is 1 out of 25.